I, and I'll have dwixi plus dxiwi plus dbi would be the differential. This would be how so I'm almost done. That's the good news. So if I make a little change, I like to think of this as like 0.001 changes. I don't like infinitesimals. I like 0.001s. That's how I think of them. But you make a little change here, a little change here, a little change here, you get a change here. You'll get this. You'll get this linear function of the perturbations here gives you perturbations here. Okay. Well, I've only got 1 minute, so I'm going to write all this out with linear algebra because everything is better when written out with linear algebra. So I'm going to write down that I'm actually interested in the last element. But dx dn plus 1 is going to equal, and I'm going to have a couple of matrices here. Let me just sort of get the structure right. This will be dx2 dxn plus 1 again. Sorry for the squishing. Okay, but here, in fact, I'd like to use block matrices a little bit. So here I'm going to have dw1, db1. I'm going to put the bias together. Sorry for the mess. But and dwn, dbn. Julia lets you make block matrices, and you can actually use them directly. There'd be a special type right there. Okay, and then what goes here, you could actually see what it would be. It would be, I hope I'm doing it right, but there'd be a delta 1 x1 and a delta n xn, and this would be a diagonal matrix. Okay, and then what do I have over here? Here, I'd have the delta w's. And if you check, you'll see that this will be, I'm not going to get the indices right, and I don't have time, so I'm just going to write it like this. And now I'm just going to give you the end of the story because I've run out of time. You could write all this